Hello you cool cats and kittens, this is a quick and dirty using Roman numerals when naming compounds tutorial. Alright, well when we first talked about naming, we did ionic, then we did covalent. Well now we're looking at the transition metals. Hopefully you got your sheet where we highlighted several columns. We also put at the top looking for weird. Remember, transition, they're transitioning. They could have different charges and we have to investigate to find out what charge they have. So we'll jump right in and do an example problem. So when you see copper, you put your finger on it. Oh wow, it's highlighted. That means it always gets a Roman numeral. So you have to put your X up at the top for the unknown charge. Put your finger on sulfur. You see that it has a -2 charge. Okay, now you're going to do a little bit of algebra. You can do it in your head or write it out. I'll go ahead and write it out for you. So you know X minus 2 and the whole compound has to equal 0. So you can quickly solve that in your head and you see that the answer for X is +2. So the answer for this name would be copper 2 sulfide. That's all you do. That's it. So let's try this next one. It's a little more complicated. So again, we see copper, we put our X. We already know sulfur is -2, but this time we have a 2 at the bottom. What are we going to do with that? Well, when we set up our little algebra here, 2x minus 2 equals 0. So I'll let you look for a second. Do you understand that I said 2 times x minus 2? There's nothing down here, so it's an understood 1. So that's how we get this equation. When you solve for that x, you should get x equals +1. Okay, it's not a math class, but you should know how to do those very simple algebra skills. So we'll go ahead and jump right in and write the name. Copper 1 sulfide. So look at those two formulas. Do you see the difference? Okay. Hopefully you'll understand that just by looking at something you can't necessarily name it correctly. You may have to do a little investigation work and put your X up there and solve for it. Let's try the next one. One of our favorite real life substances here. This is rust. So we don't know what charge the iron will have because it's highlighted. We look up oxygen, it's -2. So how do we set this up? 2x minus 2 times 3. Some of you may have just said -6 there. But when you solve that for 0, you would get x equals +3. Okay, you may need to brush up on your algebra skills if you're struggling with that, but that's not really chemistry. That's your math that you should have before you walk into chemistry. So we know our X is 3, so now we can clearly name it iron 3 oxide. Okay, last one here when we're actually writing the name, we don't know titanium because it's in the transition metals. So a lot of people struggle with this when they say, but Mr. Key, it's not highlighted. But it's still a transition metal and you're not quite sure of its charge. If it's 2, don't put a Roman numeral because it's normal. Normal state for the transition metals is 2 if you had to guess one. But now we all know that phosphate, now that we got the X on titanium, we remember our polyatomics is -3. If you don't know it's -3, then you've got to look it up on your polyatomic sheet. And when you put your finger on it, you'll see phosphate right there, PO4 -3. So if you know that, that saves a step, doesn't it? So now we're going to simply do our math. 3x minus 12 equals 0. You see where I got the 3x? You see where I got the -12? And equals 0. So we're going to go 3x equals 12 and x equals +4. So the name of this one would be titanium 4 phosphate. Oops, put the P on the wrong side. Sorry about that. Titanium 4 phosphate. Let you look at that for a second. All right, let's jump in. What if I give you the formula? A lot of people think these are a lot easier because nickel 3 obviously has a charge of +3. Yes, is that obvious? Chlorate, polyatomic, I'm going to use my parentheses, ClO3 with a -1 charge. Some people get intimidated, I tell them to cover up a polyatomic. Now you would note that your 3 comes across. So there's your work. If you want to pretty it up, let's go Ni parentheses ClO3 3. And that's the formula for nickel 3 chlorate. Let's jump right in and do manganese 4 oxide. Now this one's actually a little trickier than you would think. Manganese 4, oxygen with a -2. Now if you jump right in and cross your charges, you've got a fraction. This looks like a ratio of 2 over 4. So what do you do in math with fractions? You reduce them to lowest terms. So that's going to equal MnO2. Okay, that's a very good catalyst we use in some of our AP labs. Next one, lead 2 nitride. Be careful, this is nitride. So lead, you look it up, Pb, plus 2 charge, I give it to you. Nitride, N -3. And it's got the -3 because, of course, this is positive. It has to be the opposite. So we'll choose -3. Simply cross your charges. And then you have your answer of Pb3N2. Not bad, not bad. Last one here. Chromium 6. Wow. They go all the way up to, I think we have one at 7. So we go chromium with a +6. Bromate ends in 8, so polyatomic, O3 with a -1. Again, cross your heart. Don't have to bring the 1 down. So here we go, Cr parentheses BrO3 6. All right, hope that helped using Roman numerals. Have a great day.